And just like translating, sometimes things are going to be inside the function, sometimes outside the function. If a negative sign is outside of the function, as it is in this first one, see how that negative is outside of that function? That's going to affect things vertically. Everything outside affects the y, everything outside affects vertically. So it will reflect it vertically down. And I labeled the point 8, 4 on there. That point, the y value is changing, and I'm just multiplying my y value by a negative. If I multiply my y values by a negative, it has the effect of flipping it over the x-axis. And I'd like you on the side to write a note with the negative on the outside. Sometimes that negative is outside there, sometimes the negative could be moved with the y. So write this note down. If the negative is outside the function, aka with the y, then this is a vertical reflection, and a vertical reflection is reflecting it over the x-axis. And as a result, the y values get multiplied by a negative 1. So just like I picked that point 8, 4, when I do that transformation with the negative, that point will change to 8, negative 4. Because we took our original graph and flipped it over the x-axis. If the negative is inside the function, inside affects x's. X's are horizontal. This will be a horizontal reflection. So I take that original red graph and flip it over the y-axis, which would flip it over to there. And now my x-coordinate, so my original coordinate was 8, 4. If that got flipped over, it would be all the way over here at negative 8, 4. And so we can write a note with this as well. That if that negative is inside the function, which means the negative is with the x, this is a horizontal reflection. It reflects it over the y-axis. And our x values will get multiplied by a negative 1. I think we have time for example 1. I'll let you finish writing this down. Here's the graph of g of x. Sketch the image graph after a reflection in the y-axis, and we have to decide which one is that. Is that horizontal or vertical? Okay, over the y. I actually like take points in my head and I move them, like, which way are they moving? That's horizontal, right? So I see this, I tell myself that's horizontal. I might even write function notation. Horizontal is inside the function with the negative. Those are all different ways this question could be asked. If I do that, I'm going to take this original 4 points and flip them over. So this one's 3 away, so 3 away. This one's 1 away, I'm going to flip it, 1 away. This one's 3 away, 1, 2, 3 away. This one, 1, 2, 3, 4. And play connect the dot. Okay. You could also, and I'll just highlight it with 1, this point was at 5, 2, and now on my blue one, the negative is with the x. It's at negative 5, 2. That shows up perfectly that way. Domain and range, I'll quickly finish. Domain and range, I'll just do one notation here. Smallest x value is negative 5, biggest x value is 3. Range, smallest negative 2, and the biggest is positive 2. And for the original one, smallest x value was minus 3, biggest x value was 5, and the range. And one thing to notice here is your domain is what changed because it was horizontal. It changed your x values. Your range did not change. And if we look at our domain, see how the 5 became positive 5, the 3 became negative 3? All right, we'll continue with this tomorrow.